All right, we're back. We're on page 11 of notes 15 of Calc AB, and what we're going to do here is we're going to take limits of Riemann sums and turn them into definite integrals. Then we're going to let our calculator just evaluate them. So this is a really common thing to do. Is it? I don't know. This is a kind of common thing to do, I guess. So let's see. So one of the issues you're going to run into is that there's more than one way to do this, and it's that can kind of cause some discomfort at first. So what I like to do is I like to focus in on what is, or what do I think that delta x is. So delta x is usually just sitting somewhere as a constant multiple. I think delta x is 5 over n. So I'm gonna jot that down and say I think delta x is 5 over n. Once you have delta x, your next objective, figure out what x sub I is, because if we can find x sub I, we can like highlight it or circle it or whatever and use that to figure out the function. So I'm actually going to do this two different ways. I'm going to say that I think that x sub I is 3 plus 5i over n, right? That 3 plus I delta x. And delta x is 5 over n, so 3 plus I times 5 over n. That makes sense to me. So I'm going to say x sub I is 3 plus 5i over n. Now, what you want to do once you find x sub I is you want to find x sub 0 and x sub n. So x sub 0 is going to be a. That's where you start your definite integral. And then x sub n is going to be b. That's where you end your definite integral. So x sub 0 is going to be 3 plus 5 times 0 over n. So just 3. And then x sub n is going to be b. That's 3 plus 5 times n over n. So 3 plus 5 is 8. And f of x would be, I got to move something. As usual, I'm like really bad at using the space available, which is like essentially an infinite amount of space. So I think f of x is root x. So I think this is the integral from 3 to 8 of the square root of x dx. Okay, totally fine and good. There's another equally compelling answer, and let me just show you what I think it could be. So an alternate approach, different color, an alternate would be that delta x is still 5 over n, but now xi is just 5i over n. And if that's the case, then we think f of x must be square root of 3 plus x. So I'm saying that delta x is 5 over n. I'm looking at this and I'm like, well, I think this is x sub I. I think it's just 5i over n. Well, if that's the case, then you're doing radical 3 plus x sub I, so radical 3 plus x. So I also think that I could write x0 would be 0, and xn would be 5. I think I can also write the integral from 0 to 5, square root of 3 plus x dx. What I want you to do a u substitution on this. Let u equal 3 plus x. If u equals 3 plus x and x is 0, then we get 3. If u equals 3 plus x and x is 5, then we get 8. And then this, if u is 3 plus x, this is the square root of u, square root of u. And then if u is equal to 3 plus x, then du is equal to dx. We get this. So you can write like an infinite number of definite integrals that are equivalent by u substitution. And if you get a different answer from someone else, it has to just differ by u substitution, or it might actually be wrong. So we can use a calculator on this, but let's just keep going. I mean, those are definitely right. So let's keep going and see what we can do here. Swear, birds. Now the birds are going crazy. I don't know. I actually went back and watched the previous video where like a squirrel showed up and started just going nuts. You could hear it initially, and then the microphone somehow magically like just blocks it out. I don't really know how. All right, we need a delta x. So delta x, it should be a constant multiple somewhere. 3 over n works. So I'm going to say delta x is 3 over n. Okay, so now if delta x is 3 over n, I look at this and I see 2 plus 9i over n. Well, that's a little weird. So what I'm going to do is I'm going to change that up. Say this is the limit as n approaches infinity of, it's like, honestly, what are the animals doing today? I'm going to rewrite it so that I can see delta x. So 2 plus 3 times 3i over n. Okay, so I'm going to say that x sub I is 3i over n, and that means that f of x is the square root of 2 plus 3x. So I chose my x sub I to be 3i over n. So here's that. So now my function is 2 plus 3x sub I, so square root of 2 plus 3x. So I think this definite integral, oh, we got to find x0 and xn. x0, xn. So x0 is 0, xn is 3. So this can be rewritten as the integral from 0 to 3, square root of 2 plus 3x dx. What's interesting is when we check these or get them on the calculator I think will not be able to do the limit. So we can make like just make n like 5,000 or something, get an approximation. But because the calculator doesn't have built-in functions for like summing up these things, it's not going to be able to do it most likely. So this one was a little more challenging. I would say this is like more challenging. Let's say difficult, more difficult because of we have a multiple of x sub I. I don't know what we have multiple of. Multiple of like x sub I or something. X sub I is being multiplied by something. It's just a little more difficult. You got to like pay attention to your delta x and your x sub I. How many of these are there? Holy cow. All right, I'll do one more and then I guess check them. And this one's really straightforward though. So if you look at it, delta x should be the constant multiple hanging around. X sub I can see two choices. So I'm going to say x sub I is 3 plus 3i over n, right? Which is 3 plus I delta x. And then that would mean that f of x is just the square root of x. Or we could say that delta x is 3 over n. X sub I is 3i over n. And that'll make f of x the square root of 3 plus x. So both of those are totally valid. So this would become the integral from, so we need x0. x0 is 3, xn is 6. So from 3 to 6 of the square root of x dx, or the integral from x0 is 0, xn is 3, 0 to 3, square root of 3 plus x dx. I don't know why, like 1, 2, 3, 1, 2, 3, 4. Oh, tough call, tough call. I'll do one more. I don't know. I'm gonna keep doing one more until I like end up doing them all. 1, 2, 3, 4. Should have been an even number. That would have been the thing, but I didn't do that. All right, this one I think though, there's not much to mess around with. So xi is 2i over n. Let's find them because I keep forgetting. x0, xn, and then f of x is sine of x. So this will be the integral from 0 to 2. By the way, we don't need a calculator on any of these because we can find antiderivatives for all of these. Like it's not impossible, but it doesn't really ask us to. Should I just finish these? No, it's probably too much. All right, calculator and check, and then we'll like go from there, right? And also, stupid mic is not showing me that it's recording, and I can't even tell you. So like when you're gonna do hours of recording, the last thing you want is for your audio to just kind of like dump out on you. And I don't know what to do about that. I could restart my computer, which I haven't done in like months. problem. All right, so first thing I'm gonna do, how am I doing this? I'll do 3 to 8 square root of x dx. Okay, that's fine. Let's get a decimal. And then let's also do 0 to 5 square root of 3 plus x dx. Same decimal. And then, so the limit's not going to work. I mean, I could show you that, but I'm afraid it's going to like crash my computer. 1 to n of, I don't know, 5 over n square root of 3 plus 5i over n. Let's make n be like 1,000 and we'll get a decimal. So you can see like super close. We only use 1,000. We're supposed to use an infinite number. So, you know, but we got it right. I think you can tell from there that we got it right. So the next one we did the integral of square root of 2 plus 3x. X is a variable going from 0 to 3. You should just use a template, but you know, I'm not. So there. I 1 to n 3 over n square root of 2 plus 9i over n. And then let's do n is 1,000 again. And you can see like super, super close. We definitely got it right. For the next one, we thought we could do from 3 to 6 square root of x dx, or the u substitution equivalent, which would be from 0 to 3 of square root of 3 plus x dx. Same value. And then if we do this thing with like 1,000, I guess, n of 3 over n square root of 3 plus. This one was actually easier than the previous one. They're clearly, in my opinion, in the wrong order in the notes, but I'm not going to change them. Close enough. And then we also did this sine one, which, like, I don't know, like, what are you going to do if you don't know the fundamental theorem on this thing? 2 over n sine of 2i over n. We'll go with 1,000. Got to be in radians. If you're not in radians, I don't know what you're doing. And then we did the integral. I should just define integral to always default to integral. Like, you know, when you mistype something all the time and you like just eventually autocorrect like learns it. I should be my own autocorrect. 0 to 2, 1 point, like super, super close. Okay, so I think that we're doing a good job on these. I'm gonna come back in the next video and finish this page, and then I guess go on to the next page, which, so we're like a page and a half away from the end of these notes. That's kind of exciting. All right, so I'm gonna stop the video here. I'll be back in the next one to do some more, so see you there.